Hey, what's up, guys? Welcome to my algebraic geometry video. So hope you guys subscribe to my channel. If you want to see more algebraic geometry, then you can check out my list below. Or you want to see more interesting mathematics, or however, you can check out my video list. There are thousands of videos that you can enjoy. Okay, so I think previously I say a fact which is called the open immersion. Open immersion. Okay, so the strategy is that the idea is that we start from a fine skin, which is a local ring space. Oh, sorry, general skin, which is a locally ring space. And I say that you take an open subset of X, then you can get U and all X restricted to U. Right, so this is just the sheaf restricted to the subset, open subset. And I claim that then usually this guy is called the open immersion of this guy. Okay. And the fact is that this guy is a skin. Okay. So basically what I'm saying is if you take an open subset of a skin and defined by or using this open immersion, so sheaf will just retreat is a skin. Okay, so usually if you see a textbook, this is very short. You just read a sentence. And so this video will just give the proof. Okay, so you might think that this proof is trivial, but maybe you need to think a little bit. It's not so trivial as you think, right? This is not like topology, right? Because if you want to say skin, then you need to prove that any points, right, X, there's an open cover which is a fine. Okay. So let's write down a round proof. So for people who think this is trivial, maybe you think so easily. The reason is that right, so by X is skin, right? Since X is skin, so I know that for every X belongs to X, there is an open neighborhood. There's a U. It's called UX, right? Such that this is open, such that UX, right? Such that when UX is a fine, right? Okay. So you might think, oh, so I mean, it's very good that I can write X into this fine cover, right? So I can say that, oh, so U intersection with X is guy, right? And the U intersection with UX. Okay. Then you might think that, oh, this guy just definitely has U, right? So this guy is so this U has a fine cover, right? But the problem is that this guy may not be a fine. Okay, so this is a wrong proof, right? Because U intersection with UX is a two. This guy's open set, right? This guy is a fine, right? So you're getting the open subset of a fine. So, but the problem is that the open subset of a fine is not a fine in general. It's not a fine. Okay. The example is that I think it's my previous video, or I think it's my future video that I will prove. So basically, is that if you take the affine plane, right, minus the origin, right? So affine plane minus origin, obviously that this guy is open, right? You can check that this guy just distinguish open set union X, right? Basically just saying that X is non-zero, union of distinguish open set Y. So this guy just tell you that either X or Y or one of it must be non-zero. Okay, so this guy is open, this guy is open, so definitely it's open, but this guy is not fine. You can in the future I will prove this. So this guy is not fine. Right, so this proof is actually incorrect. Okay, so you need to think a little bit to see why this is a fine. Okay, so actually the fact is the following. So this U, right, is true that there is a union of this. Maybe I use this U. Okay, maybe I use this U. Okay, so this U, right, is generally looks like this. This is correct, right? But the problem is that this is not fine. Okay, but the fact is that even though it's not fine, it's still a subset of a fine, right? So the one sentence is that the distinguished open set forms an open basis, right? Forms a basis. So U intersection of U of X can be written as a distinguished open set, maybe a lot of them, right? So maybe F. Let's using maybe beta, right? And X and beta. So given X, I have so beta is a set corresponding to X. Right? So beta is whatever, right? Okay, so now I can write U into a union of X, and the union of X beta, D of beta. Okay, so once you return this, then you finish your proof, right? Because now this distinguished open set itself, this guy itself, is affine. Okay, so this is not difficult to prove. Basically, you can, D of F is affine, or single F, or for multiple or any set, right? Is affine, right? But the union of D of F, but let's see, a union of D of F may not be affine, as the previous example that we have seen, may not be affine. Okay, so yeah, the previous example I say, right, D of X union D of Y, right? So either is X is on 0 or Y not 0, this guy is not fine. Okay, so this is that, but this guy, this small D of F for each one is fine. Okay, so this is distinguished open set. Yeah, the reason is that I mean, you can prove that I think this is already said, right? Because if you take the global function D of F, right? Distinguish opens at X, yeah, you take this and the structure shift on D of F, then the global section will be just AF, right? So it just be a ring localized in F, sorry. So these guys are fine. Okay, you can check that D of F just by definition. Okay, so now you can write D as a affine open cover, but the affine open cover may be a lot, right? It's completely different from the original one, right? Maybe original one, maybe you have fewer of them, right? But now each one will spread into a lot of them. Okay, so this is the proof why the open subset of skin is open immersion skin. This is a little bit non-trivial. See you guys next video.